Let's look at the assignment from yesterday. So Jimmy went to a local convenience store 2 days this week. On his way home from school, on Tuesday, he brought 2 candy bars and 1 soda and spent $3.26. On Thursday, he bought 1 candy bar and 2 sodas and spent $2.67. Find the cost of 1 candy bar and the cost of 1 soda. So C would be your cost, right? Because we already know how many, so it'd be cost of a candy bar. Because it says cost of 1 candy bar, and S would be cost of a soda. So this is different from our examples that we did yesterday. So then when we set it up, so this would be my Tuesday equation. 2 candy bars plus 1 soda, $3.26. And then Thursday equation would be 1 candy bar, 2 sodas, $2.67. Find the cost of 1 candy bar and the cost of 1 soda. Solve the system. So we would use this system of equations to solve it. So there are different ways to do it. You could solve one. We could do substitution or elimination. So I'm going to show you elimination. So this would be, we could do the S. So I'm going to do that times a -2. 2C negative 4C, sorry. Minus 2S equals 326. And then we have 1C plus 2S equals, I didn't multiply that. Sorry. So we would do -2 times 326, -6, 52. So then when we add them up, we get -3C equals -385. Then divide by a -3. So C equals 128. Because we're talking about cost, so we round it to the nearest penny. So $1.28 for candy. Okay. And then we need to find out what the soda cost. So we could use the first one. 2 times 128 plus 1S equals 326. So I plugged it into the first equation. So 2 times 128 would be 256. And then subtract the $2.56. That was the 2 candy bars. $0.70. Okay. So then we need to double check our work. So we need to do 2 times 128 plus 1 times 70 cents. See if that equals 326. And it does. And then you can check the other one. 1 times 128 plus 2 times 70 cents equals 267, 268. So why would this be off by a penny? Like it's really close. Because we rounded. Yeah, we rounded right here, which caused that to just be off by a penny. But that's okay.
Is it okay if I got 69 cents instead of 70?
So if you would have used this, so let's use that. And then do times 2, and then subtract from the 326. Oops. Yeah, you could have done that. if you wouldn't have rounded in the beginning on the candy bar, then you would have gotten the 69 cents here. But, yeah, because of the times 2 would actually be 57 if you rounded. So it depends on where your rounding is. Okay, so label your answer. So we need to write it in words. So the candy bar cost $1.28, and the soda cost 70 cents. Okay, let's look on the other side. Okay, so this is the high school drama club hosted a spring musical. The club charged $3 per child and $5 per adult. A total of 374 tickets were sold, raising $1,524. How many child and how many adult tickets were sold? So we have, it's wanting to know how many child and adult tickets were sold. So we would say C is the number of child tickets sold. And A is the number of adult tickets sold. So then we would have 2 types of equations. Because they give us this information, we know total number of tickets is one equation and total amount of money is another equation. So this one represents amount of money. 3C plus 5A equals 1,524. And then the other one is the total number of tickets. So that'd be child plus adult has to equal the 374. Okay, so this one can be solved elimination or substitution, either way. 3C plus 5A. Who likes elimination better? Who likes substitution better? Okay, so elimination is kind of y'all's go-to. Okay. So if I were to do this, I could multiply the bottom by, what do we want to do? Do we want to do -5 or -3? -3, yeah, so we deal with smaller numbers. So 3C plus 5A equals 1524. -3C minus 3A equals, what's 374 times -3?
I got -1,222.
1,000, what?
1,222. No, 122. What?
1122.
11.
No, we got 1222. We got 1,122.
374 times 3. 1122. Okay. All right. So then this cancels. We have 2A equals, what would that be, 402?
Yes, ma'am.
Okay. Divide by 2. 201. Okay. So our adult tickets is 201. We need to find out our child tickets. So couldn't we just take the total minus the adult to get the number of child?
Yeah.
Okay. So that would be 163. Is that right?
73.
73. Okay. Thanks. All right. So label your answer. So 173 child tickets were sold. And 201 adult tickets were sold. Okay, we are going to practice this more. I feel like we need a little bit more practice with different kinds of these type of problems. So I'm going to pass out a foldable that we're going to use. Okay, so let's look at the foldable. Problem solving with systems of equations. Define your variables. What are your two unknowns? Step 2, write your two equations. Step 3, solve your system using any method. And step 4, write your answer in a sentence. Relate back to the situation. So we've gone over all these steps. This is just more of an outline of it. So let's look at our first example. If Mark and Kyle combine their hourly pay, they would make $16 per hour. Mark's pay is $1.50 more than Kyle's. Find the hourly pay for Mark and Kyle. So step 1 is to define your variables. Usually you can look at the very end of your word problem. So find the hourly pay for Mark and Kyle. So that would be your variables. So I'm going to say M is Mark's hourly pay. So then K would be Kyle's hourly pay. So we have M and K. Now we need to write our system. If Mark and Kyle combine their hourly pay, they would make $16 an hour. So what operation takes into account for combining? Huh? We're going to add. So their hourly pay combined is $16. So M plus K equals 16. Then the other part that we haven't used yet is Mark's pay is $1.50 more than Kyle's. So we need to write it in an equation that says that Mark's pay is $1.50 more than Kyle's. So anytime it says Mark's pay is or something is, that means equals. I'm going to put equals underneath the is. So M equals, because it's Mark's pay is $1.50 more than Kyle's. So more is addition. So we're going to take Kyle's and add $1.50 to it. So it's Mark's pay is, so M equals $1.50 more than Kyle's. Usually that's a switch around word. So looking back at that green foldable from quite a while ago, I think it might have been the first section. Do y'all remember? Oh yeah, right here. The words in algebra. It's one of those turnaround words. More than or less than. With addition, it really doesn't matter if you do plus or minus. I mean, with addition, it doesn't matter which order you go. But it is a good habit to go ahead and switch those anytime you see a more than or less than. So that'd be Kyle's pay plus $1.50. Okay, so solve your system using elimination. Which one looks like it would be easier on this one?
M equals K plus 1 because it's already solved.
This is already solved? Yep. So since this is already solved, what method could we use easily? Yep. You can rearrange it and do elimination if you'd like. It's just up to you, but this is already solved. So instead of saying M plus K equals 116, I'm going to sub in this K plus 150 for that M, because it was M plus K equals 16. M equals K plus 150. So this is going to be subbed in for M. So this would be K plus 150 plus K equals 16. So then combine your like terms. 2K plus 150 equals 16. Subtract 150. 2K equals 1450. Divide by 2. K equals 725. Okay, so we have K. So now to find M easily, we can say M equals K plus 150. So we already know what K is. So we'd say M equals 725 plus the $1.50. So M equals,
875.
yeah, 875. So it's $1.50 more, which goes right along with what it said here. And then we just write it in words and then make sure that it really, truly does make sense in here. Combined is $16. If we add these together, does that make $16? Yeah, you would take the 75 cents and the 25, making $1, making that 8 plus 8, 16, right? And then this is $1.50 more. Okay, so now we need to write it in words. So Mark makes $8.75 per hour, and Kyle makes $7.25 per hour. Okay, let's move on to the next one. Jason empties his pockets on his dresser every day. He has accumulated 30 coins in dimes and quarters. Their total value is $4.50. How many coins of each type does he have? So let's define our variable. It usually comes at the question. So we could say, yep. So D for number of dimes. Q for number of quarters. And you were given a hint for your two equations. One's dealing with the quantity of coins, and the other one's dealing with the value, basically how much money it is. All right, so equation for quantity. How many total? 30. And what makes up that 30 is the D plus the Q. And their total value is $4.50. So however many dimes we have, we'll multiply by how much a dime is worth. So 10 cents times your number of dimes plus a quarter's worth 25. So it'd be 25 cents times how many quarters we have is going to give us $4.50. Okay, so both of these are written in standard form, like an A, B equals a C. So this one, it looks like elimination would be an easier method. So I'm going to rewrite it down here. Okay, so what would we want to eliminate, the D or the Q? Which one would be easier because it's smaller? The D. So we'll multiply everything on the top equation by a negative 10 cents. So that'd be negative 10D plus negative 10Q equals, what's 30 times a negative 10 cents? 30 times negative 10. Negative 3. Okay. And then rewrite your other equation. So those would zero out. So negative 10 plus 25 would be 15Q. 15 cents Q equals $1.50. Divide by 15 cents. Q equals 10. So that means we have 10 quarters. So then we look back up here. Okay, we have a total of 30 coins together. So if we have 10 quarters, how many dimes will we have? Then we just need to check our work. I'm going to use the calculator for that. So I'm going to multiply the dimes times 10 cents, 25 cents times the 10, and then see if I get 450. We'll probably do it on our head. I'm just going to show you all. That would be 20 plus times the 10 equals 450. Okay. All right, so write your answer in a sentence. So looking back, it says how many of each type does he have? He being Jason. So Jason has 20 dimes and 10 quarters. Okay, let's finish up slide 13. Everybody look at slide 13 now. We're getting close to being finished with this unit. See how we just have 14 and 15? And that's graphing systems of inequalities. So slide 13 is about estimating systems graphically. A system of equations, A plus C equals 950 and 6A plus 4C equals 4,840 can be used to determine the number of adult tickets A, number of children tickets C to a zoo. Use the graph below to estimate the number of tickets, adult tickets sold. So let's look and see. If we have this graph, we need to recognize what the axis represents. So it's not X and Y. In this case, it is A and C. And we want to know how many adult tickets are sold. So we would need to look for A. So see how the x-axis is labeled A? The y-axis is labeled C. So using these two systems, or these two equations as a system, we could find out what satisfies both of these systems. And that's your intersection point. Okay, so we need a point. Were we given a point anywhere? Oh, yeah. We were given this so we can circle it. So go over and grab that little circle and pull it over here. Okay. I'm going to zoom back in so we can find out what that point is. So we are estimating. So I think I need to zoom in a little bit more. Okay, so the point of intersection is around there. So we're looking at A. Where is A at? What do y'all think? Around 500? So let's look at our answer choices. What are our answer choices? Which one's the closest? 525, yeah. So if you look, okay, here would be 550 between the 500 and 600. So halfway in between, if I do my line up, looks pretty good to me. And the children tickets would be your y-axis, which would be about 425. So just pay attention to what your axis are labeled. I'm going to copy and paste that little circle so I can put the circle over the answer too. And I need 2 more of these for the next problem. Go over. Okay, so let's look at the next one. Here is the system of equations. D plus N equals 95. We have 10 cents D plus 5 cents N equals $7.75. Can be used to determine the number of dimes D and nickels N in a child's piggy bank. Use the graph of the system to determine which of the following is best estimate for the number of each type of coins. So let's find our intersection point. Oh, don't want to do that. So right around there. So D is our x-axis. So D is right around 60. What do y'all think?
Yeah.
Okay, and then N is the number of nickels, which is under 40. Okay, 35. That works. All right, awesome. There we go. Okay, so I'm going to give you your assignment, which is very similar to the foldable that we just finished. So I'll post that